Hi everybody, welcome to this video. My name is Jonathan Monga and I'll be leading you through this physics problem. Our questions are, first we've been asked to find the magnitude of the acceleration of this system, and second we've been asked to find the magnitude of the contact force. So if you stick through to the end, you're going to discover just how we can do that. Okay, so the first question we're solving, as I said, is finding the magnitude of the acceleration. So how do we find the acceleration? First of all, we're going to list down the formula. That's the first thing I suggest anybody doing physics do. You first list down the formula that's most applicable. You experiment with that. So according to Newton's second law, we have this formula right here. Summation of all forces is equal to the mass times the acceleration. Now let's break it down a bit. We have acceleration right here, which we are trying to find. So the best case scenario of finding this problem is making acceleration the subject of the formula. Before we get to any of this, we have to look at how the system is and how acceleration is being applied. So when you look at this, we have two masses here, right? Of course, the force is acting, one force is acting on both masses, so the acceleration will be the same. And I know some might ask, what about gravity? We're ignoring gravity. Well, in this situation where it's rested on a surface, and the question specified that this is a frictionless surface. I forgot to mention that, but this is a frictionless surface. So it's resting on a surface, there is no friction, so the force is not being opposed by any friction. And the gravity, which is mass times gravitational force, the weight, as per se, mass times gravitational force, is being opposed by the normal force, which we call N, the normal force. Because this is on a surface, it's not accelerating in the y direction, it's only accelerating in the x direction. As of such, acceleration is said to be equal to, acceleration's normal force is said to be equal to the weight, which means we ignore all forces acting in the y direction and only focus on the forces acting in the x direction. Okay, let me draw my surface. It got erased a bit back there. All right. So going back to our equation, now that we've defined the acceleration, and now that we've said the weight won't be considered, let me just go ahead and erase it. The normal as well won't be considered, right? Now, what we're going to do is fill in our values or make this formula more detailed. So since we're only acting in the x direction, we're going to say summation of all forces in the x is equal to mass. What we know about mass is what it's acting. We have two blocks, so we're going to sum the masses. We have the m1 and the m2. Then we only have one acceleration because it's one force applying on both masses, so acceleration will just be one. Okay, great. Now before we even go further, let's define our directions. That way, since acceleration is a vector, we have to know which directions we're working with. I'll define the top part as positive y, and I'll define the right as positive x. Now that we have this formula right here, the only thing we have to do is make acceleration the subject, which we can do by dividing the entire right side of the equation by m1 plus m2. And if you remember math, whatever you do on the right or the left must be done on the opposite side as well. This should be m1 plus m2. We find that this cancels, we remain with acceleration, which will be summation of all forces in x divided by the first mass plus the second mass. Okay, this is our answer for the first question. Let me go ahead and write it down so we can store it and we'll be able to use it in the next question as well. So acceleration is equal to summation of all forces in x over m1 plus m2. Great. Okay, so the second question states, determine the magnitude of the contact force. Let's break it down a bit. So between these two masses, we have mass 1 and mass 2, there exists a contact force. So as much as there's only one force being applied on both m1 and m2, m2 being an independent mass is having some resistance, is resisting the motion of m1, or is resisting the motion of the force. So meaning as much as the force is great enough to overcome the resistance, hence accelerating this in the right direction, it first has to overcome the resistance from M2, which is being applied on M1. And that's what we're calling the contact force. We'll denote the contact force between these two. Welcome to the second question. So the second question, B, says find the magnitude of the contact force. So let's break it down just a bit. So we have two masses, M1 and M2, and only one force being applied on them. As we already established, the mass being applied on the weight being applied downwards is opposed by the normal force. So for both masses, they are not experiencing any type of downwards motion or upward motion. They are not experiencing any type of motion in the y direction. They're only experiencing motion in the x direction. So we are going to ignore all type of motion in the y direction, just to restate. So the contact force is a force that exists between M1 and M2. Since M1 and M2 are independent masses being accelerated together by the force of F, M2 is going to have some kind of contact force on M1, and M1 is going to have a contact force on M2, which is the main force pushing M2. M1 is being pushed only by the force, but is being resisted or dragged backwards by M2. So just to understand what I'm trying to say, let's break down the forces or the masses into individual components. So we're going to have M1 right here being acted on by the force F. So what I'm trying to say is, since M1 is attached to M2, as M1 is being pushed by force F, it's experiencing a contact force from M2 that we're going to call P. And since this contact force is from the mass 2 on mass 1, we're going to say P21, meaning the force is applied from mass 2 to mass 1. That's what that means. So to find the magnitude of this, we're going to apply yet again Newton's second law of motion. We have the summation of forces in the x direction times the mass 1, which we're working on currently, multiplied by the acceleration of the system. And if you remember correctly, we said the acceleration is the same because it's being accelerated by the same force and they are attached together. So summation of forces in x is equal to mass 1 times, we're going to plug in our value for acceleration, which is the same throughout this whole system. So we're going to have summation of forces in x over m1 plus m2. You can write it like this, or if you want to be a bit more complex, you can even say, on the first question, you can even say acceleration is equal to all forces. You just say F because there is no other force, so you don't even have to specify. You can just say F over M1 plus M2 for easy calculation, right? That's what I'm going to do right here. Of course, this is also okay because it's the summation of all forces in X, but I'm only simplifying it because we have only one force happening in X at this particular point. Okay, so this is going to be force over M1 plus M2. Now the summation of all forces, when you split it and when you're looking for the contact force, you're going to say the force happening on M1 minus the contact force being applied by M2 on M1. We're going to call that P21. All this is equal to M1 times the force over M1 plus M2. Hopefully we're following at this point, but we're only looking for the contact force, which is P1 on 2. So that implies we're going to have to transpose F to the other side, or transpose everything here to this side and the contact force to the other side, just so we could have it as a positive, which I'll do. Hopefully you can follow how I'll do it, but this will leave our contact force as positive. If it travels to the other side, our force is going to become it will remain positive since it's not going anywhere. We're taking this and bringing it on its side. We're going to have force F minus m1. For easy calculation, I'm going to combine these two by a multiplication. F over m1 plus m2. Okay, so from here we can already see our contact force formulating before our eyes. So what we're going to do, which I'll do here, is just rewrite it and factorize it for better calculation. We're going to have our contact force as F is common in both equations, so we're going to factorize F. That gives me 1 minus m1 over m1 plus m2. Okay, from here I can go a step further and say I have my force. So I can go a step further and make this over one denominator, which will be m1 over m2, because that's a common denominator. That will be m1 plus m2. 1 into this just gives us m1 and m2. We have m1 plus m2. m1 and m2 into m1 and m2, that just gives us 1. Multiplied by m1, we get minus m1. Already you can see minus m1 and plus m1 cancels out. We will remain with m2 over m1 plus m2 multiplied by the force F. That is our contact force. To write it better, we're just going to write it somewhere here. Can you help me position that? Can you help me position it? Okay. So to rewrite our equation better, I'm just going to remove all this and okay, I'm going to say our contact force, which is P21, is equal to the force times m2 over m1 plus m2. Hopefully you've been able to follow up to this point. So one might ask, what about the contact force happening on m2 from m1? And if you know Newton's third law of motion, it says, according to Newton's third law, for every force there is an equal but opposite reaction. So that would tell us immediately that the same force happening on m1 by m2 is the same force happening on m2 by m1. But just to be sure, and Newton's third law goes on to say that for every force there is an equal but opposite reaction. So our prediction here is the contact force happening on 1 due to 2, on mass 1 due to 2, is going to be equal to the negative of the contact force happening on our mass 2 from 1. But just to prove this theory, we're going to use Newton's third law to calculate the same. We're going to use the second mass to calculate it. I'll keep this right here. And bro, I'm about to wrap up. Can you just please help me point it to this direction, like the original direction? I think this should be enough to cover the whole board, right?
Yeah.
Okay.
What are you doing?
I forgot.
Yeah.
No. Okay. So to discover whether that is true, we're going to work with M2 and see if it gives us the same contact force. So writing M2 individually, we're going to have M2 on a surface the only force acting on M2 is the force that M1 pushes on M2 from the force F. So this will be acting in this direction, of course, and that is F. But in terms of the contact, we're going to call this force contact force P from acting on 2 from 1. That's the way we write it. So this means basically the force is coming from M1, but it's acting on 2. So what happens is we're going to yet again use Newton's second law of motion, meaning summation of all forces in X is equal to mass times the acceleration. And from here we can tell the only force happening in the X direction is the same contact force. So we're going to rename it P12 is equal to the mass of M2 times the acceleration. If you remember correctly, we have the acceleration there, which is F over M1 plus M2. You can already see the resemblance with that one, but I can rewrite it to be exactly equal, and that should be multiplying M and F. I get F times mass 2 over mass 1 plus mass 2. And just to equate them properly, I can also put these brackets. That shows you that the same contact force happening on M1 is the same contact force happening on M2. And yeah, that's how we find the magnitude of the contact force.